Hi, today we will be learning how to implement circular queue using arrays. Why we are learning circular queue? Was there some disadvantage with the linear queue? Yes, definitely. Linear queue doesn't uses the memory optimistically. It doesn't utilizes the memory to its fullest. How? See, in linear queue we used to use two pointers, rear and front. Recall that in linear queue the additions are done with the help of rear pointer and the deletions are done with the help of front pointer, right? But what was the problem with the linear queue? See, like for example, just recall after addition of the first element, the linear queue appears like this. After that, the front pointer is left at the first element and you add new elements with the help of rear pointer. Now, this is the situation where linear queue is full. Front pointer is pointing at the first element and the rear element is pointing at the last element. But what happens if even the first element is deleted from the linear queue? See, this element is deleted from the linear queue and front pointer has moved to the next element location. Can you see that? But now even at this situation, when the first element is free, the location is free in the linear queue, even if you try to add any element to this linear queue, because in linear queue the disadvantage is that the checking of the length of the linear queue is done with the help of rear pointer, the location of the rear pointer, right? And rear pointer is pointing at the last element of the queue. So it will display the message linear queue is full. The rear pointer will not rotate and go back to its first location to check whether it is free or not, whether that location is free or not. So this is a problem with this. But in the case of circular queue, what will happen? The rear pointer will move around and after filling up the last element in the circular queue, the rear pointer will move to the first index location to check if that location is free. It might happen that this element is deleted and the front pointer is moved to its next location. In that case, in the circular queue, the next element will be added to this location where the front pointer was pointing. So, what I mean to say indirectly, the circular queue uses your memory in a very finest way, right? Let's understand this program now. See, to make the program easy to understand, I am defining the circular queue of size 4 elements. Here I am defining a macro max of size 4. This is a circular queue array of size 4 elements. This is menu driven program, right? Here are the rear and front pointers which are initialized to -1. Whether it is linear queue or circular queue, the initial condition remains the same. The front and rear both are initialized to -1. This is menu driven program. A menu will be displayed to the user. 1 to add element, 2 to delete element, 3 for quit, right? And the user is asked to enter the choice. Suppose user enters 1. The user will be asked enter the value to add. Suppose user enters 5. That 5 will be assigned to this variable value. You are calling addQ function and you are passing front and rear by reference. See, you are passing the addresses of front and rear pointers. I hope you know that while calling the function there are two ways to pass the arguments. One is pass by value and another is pass by reference. When you pass the argument through pass by value, whatever the modifications to the parameters is done in the function, when the control comes back to the main function, all the changes made in the functions are lost. But when you pass by reference, the pointers point to the address of the parameters. Whatever the changes are made to the parameters in the function, those changes are actually performed on the arguments that are being sent. So when the control comes back to the main function, the changes made to the parameters in the function will be visible in the main function also. I am sending the front and rear so that whatever changes are made to the front and rear in the addQ method will be seen here in the main function also. Let's see what the addQ function is doing. See, this is addQ function. The front and rear will be assigned to these pointers, front and rear, and the value will be assigned to this value parameter. You are coming here and checking. Is R is -1 greater than equal to 3? No. Control will come over here. R plus plus. R was -1. It will become 0. Is 0 not equal to front? Front is -1. Yes. To this CQ0, you are assigning this 5. So the 5 is assigned to the CQ0 element position. On the screen you get the message 5 is added in circular queue. Because if block is executed, else won't be running. Control will come over here. Is front equal to -1? Yes. So the value of rear, which was 0, will be assigned to the front. So as I said, while adding the first element, front and rear will both point to this first element. After that, now only the addition will be done with the help of rear pointer only. So this function is over. Control will go back to the main function. There again a menu is displayed, 1 to add, 2 for delete, 3 for quit. Suppose user again add 1. See, why we are adding so many elements? We just want to see what happens when the queue becomes full and the first element is deleted. Let's see that. That is the main idea of this lecture. Control will come over here. Rear is 0. Is 0 greater than or equal to 3? No. Control will come over here. R plus plus. R is 0. It will become 1. Is 1 not equal to F? F is 0. Yes, 1 is not equal to 0. Control will come over here. To this CQ1 location, the new value will be added. Whatever the user has entered. We assume the user has entered 8. So 8 will be added to CQ1 location. Right? To this CQ1, this 8 will be added. On the screen you get the message 8 is added in the circular queue. Again the control will come over here. Is front equal to -1? No. So front will remain 0 and R has become 1. R is the rear pointer, right? The function is over. Control will go back to the main function. Again menu will be displayed. User will be asked whether you want to press 1, 2 or 3. Suppose user enters 1. The user will be again asked what is the value that you want to add. Suppose user enters 3. Control will come over here. Is 1 greater than or equal to 3? No. Control will come over here. R plus plus. R was 1. It will become 2. Is 2 not equal to 0? Yes. To this CQ2 position, this value 3 is added. See, the 3 is added here also. Okay. On the screen you get a message. 3 is added in circular queue. Control will come over here. Is 0 equal to -1? No. So front will remain 0. Again add queue function is over. Again control will go into the main function. Again the user will be shown the menu 1, 2 and 3. 1 to add, 2 for delete, 3 for quit. Suppose we assume again the user enters 1. User will be asked what is the value you want to add. Suppose user enters 1. Control will come to add function. Again add queue function will be called. 1 was assigned to value parameter here. Is R. R is 2. 2 greater than or equal to 3. No. Control will come over here. R plus plus. R will become 3. Is 3 not equal to 0? Yes. To this CQ3 location, this value that is 1 will be assigned. So 1 will be assigned to this CQ3 array location. On the screen you get the message 1 is added in circular queue. This add queue function is over. Control will go back to the main function. Again menu will be displayed. Let's see what happens if the user wants to add one more element to this circular queue. Let's see. Suppose user presses 1. The user will be asked what is the value that you want to add. Suppose user enters 6. Control will come over here. Is 3 greater than or equal to 3? Yes, it is equal to. That R, the value of 3 will be assigned to this R value variable, that is temporary variable. R plus 1 is 4. 4 mod. This is mod function. It divides and gets you the remainder. When you divide 4 by 4, you get remainder 0. That will be assigned to this R. Is 0 less than 0? No. Control will come over here. This R value, that is 3, will be assigned to R. That means R will become again 3. It was 0, it will become 3 again. On the screen you get the message, sorry, the circular queue is full. That means the new value will not be added to the circular queue. It is really full. If now the value is deleted, obviously the front will move to the next location 1. And in that case situation, this rear, which was 3, it will become 0. And the next value will be added to this CQ0 location. That means your memory will be used in a very optimized way. Let's see how the value is deleted from the circular queue. When the user presses 2 to delete a value, we assume that circular queue is full at the moment. This is the situation. Suppose user presses 2. Control will come over here. This del Q function will be called. Control will come over here. Is front equal to -1? No. Front is 0. Are front and rear equal? Are they pointing to the same element? That means are they pointing to the last element of the circle Q? No. Control will come over here. Is front greater than or equal to max? Is 0 greater than or equal to 3? No. Control will come over here. Fetch the value CQ0 and assign it to value parameter. CQ0 is 5. Assign it to value parameter and increment front. Front was 0, it will become 1. So front will point to this next location, which is to be deleted, right? And return value. That means this 5 will go back to the main function and will be displayed on the screen. That means first value in the circular queue is deleted. Front has moved to the index location 1. Rear is pointing at 3, right? Now again the menu is displayed. Now let's see if the user enters 1 to add a queue, what will happen? Whether the new value will be added here or not. Let's check. See, suppose user presses 1, user will be asked what is the value you want to add. Suppose user enters 6. contour will come over here. Is 3 greater than or equal to 3? Yes. 3 plus 1 mod 4. That means 4 divided by 4, remainder 0. 0 will be assigned to the rear parameter. Is 0 less than front? 1. Is 0 less than 1? Yes. To this CQ0 location, this 6 will be added, and on the screen that you get, 6 is added in circular Q. That means the rear rotates back to the first location. This is I wanted to tell you. That means in circular Q, whenever any element is deleted, rear will move to the initial locations and will try to fill it up. So that means this is the how circular Q works. Let's run it practically. I am using Kigmin software tool to run my C programs. I have written this program in C. See, circular Q air.c. This is the whole program that we were discussing. Let's compile this. I am using GCC compiler to compile these programs. See, it is compiled, no error. Only certain warnings are there. Let's run this. See, it is displaying you the menu 1 to add, 2 for delete, 3 for quit. Let's press 1. It is asking you to add the value. Suppose I add 5. See, you get the message 5 is added in circular Q. Again, menu is displayed. Suppose I press again 1. You ask what is the value that you want to add. Suppose I enter say 8. See, you get the message 8 is added in circular Q. Again, you get a menu. Suppose again I want to add. I press 1. It is asking me what is the value you want to add. Suppose I enter 3. See, you get the message 3 is added in the circular Q. Again I press 1, right? It is asking you what is the value that you want to add. I press 1. See, 1 is added in the circular Q. Again the menu is displayed. Now the circular Q is full, right? Again if I press 1 to add one more value, see, enter the value to add. Suppose I press 6. Sorry, the circular Q is full. That means you are not able to add any value. Now if I press 2 to delete a value, suppose I press 2. See, you get the message. The value deleted from circular Q is 5. That means your one value is deleted. Again the menu is displayed. If I press 1, what is the value you want to add? Suppose I press 6. See, 6 is added in the circular Q. And obviously this is added to the first location, first index location, right? That is 0th index location. So this program is working perfectly well. I'll quit from the program by pressing 3, right? If you face any problem in understanding this program, you can mail me at bmharwani@yahoo.com. For the code of this program, I have specified one link in the description of this program. You please click on the link to get the code of this program. Thanks for watching the video. Have a nice day.